Happy Friday, 7Excel students. So today we are going to talk about something that is going to bridge us into next week's lessons with what we've done this week. So this week we've talked about slope and we've talked about y-intercept and where those things are on a graph and in a table. So we're going to talk about how those relationship pieces are either proportional or not proportional. That's going to help us write the equation of a linear line that we're going to get into next week. So today, let's talk about two different things. First, proportional relationships. This should be quick and easy review. We've done this in 7th grade with proportional relationships and our ratios and our unit rate. So today, a relationship between two quantities is proportional if the ratio between the two quantities is constant. Two things that will be true about a graph that is proportional. Who remembers? If this graph right here were to be proportional, what would it look like? The graph will be a straight line, and it will pass through the origin, that 0, 0 point. So in a table, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y over x will always be constant. So let's look at one example together here. So Hillary is looking for a gym to join. One gym offers a membership for $25 a month. Use this information to complete the following. So our table here. So if Hillary joins the gym for 0 months, what will we do to find her cost? Now, we've talked a little bit about these. Hopefully it's going to cost $0 because she has not gone any months. So what would we do? Our key piece here is that the membership costs $25 a month. Okay, so that's $25 every month. And if we go for 0 months, her cost is going to be $0. All right, with that, taking a look at month 1, that would be $25. Month 2, $50. Month 3, $75. Month 4, $100. Month X, all we would do is multiply 25 by however many months we are looking for. Okay, so our cost there would be whatever our y value is on the graph. Does that make sense? Okay, 25 times any amount of months would give you where the cost would be on your y-axis, because remember, months would be on your x-axis, cost would be your y-axis. Your money is always your dependent variable. So let's answer the question down below. What is the slope or rate of change in our table? Hopefully you're seeing the rate of change is $25. Okay, so our change in our y's go up by 25. Change in your months go up by 1. 25 divided by 1, it costs $25 per month. So is this table proportional? What do you think? Yes or no? It is proportional because all of the ratios, y over x, are constant and all equal 25. 100 divided by 4, 75 divided by 3, 50 divided by 2, 25 divided by 1. Remember, 0, 0 is always going to be that origin point. So that proves to us in our table here that this passes through the origin, and this is going to create a straight line on our graph. So taking a look at our graph here, so on our x-axis, we have months. It's important to label that. And on our y-axis, that is our cost. Okay, so at 0 months, we're going to pay $0 for this membership. 1 month, it'll be $25. So I'm going to go in between 20 and 30 looking at my numbers. 2 months, $50. 3 months, $75. 4 months, $100. So if I picked any X amount of months, it would be what my Y value is, my cost. So does this create a nice straight line passing through the origin? It does. What is the slope or rate of change shown in this graph? So remember your rate of change on a graph, okay? Rise over run, rise over run, rise over run. So it went from 25 here to 50 on the y-axis, 25 to 50 is a difference of 25. And it went from month 1 to month 2 if I used that point. So second month minus the first month is 1 month difference. So your rate of change is still $25 per month if you read that accordingly. Is this graph proportional? Hopefully you answered yes. Why? Because it is a straight line passing through the point 0, 0, our origin. So looking at how we would write an equation here, we should know this. To represent the relationship between X, the number of months at the gym, and Y, the total cost of the membership. So we should remember this from our previous unit in 7th grade. So remember, our equation always starts with Y equals 25 times X. So to get any Y value, which if you look back, our Y value is our cost. So to find the cost of how much your gym membership will be, you multiply $25, that's your unit rate or your cost per month, times X, however many months, okay? So your equation will always start with Y because that's your dependent variable, and you multiply that unit rate or your rate of change by your X. So part B, do you see the slope in the equation? If so, where? You should see your slope right there. It is in front of your X. That's called your coefficient. Okay, so that's your slope. What conclusion can we make about proportional equations? Okay, the slope will be the coefficient in front of your X. So Y equals, and what goes right here is your slope multiplied by your X value. So if it's a proportional equation, we're going to write it in the form of Y equals M times X, because remember, M is the slope. Think mountain, steepness. What is your slope or your rate of change? So what do the X and the Y represent in the equation? We've talked about this earlier this week. All those are there different inputs and outputs? Those are X and Y values that make up ordered pairs on the line. Okay? So those just make up ordered pairs that are on the line. So let's take a look at this table. Okay? This shows the cost of a certain number of pounds of apples. So 4 pounds of apples cost $5.52, 8 pounds cost $11.04, 12 pounds cost $16.56, 16 pounds cost $22.08. So what is my slope here? So remember, your slope or your rate of change is your change in your Y value. Cost is always your dependent variable, divided by your change in your X value as a ratio. Okay, so to find the change in your Y value, you're going to subtract your second point, whichever you pick as your second. So I'm going to take 1104 minus 552. So the difference here is $5.52. 8 minus 4 is 4. Remember, you're subtracting to find the difference or how much that increased by. So to find your slope, we're going to divide my y over my x, 552, divided by 4 gives me a slope or a unit rate of $1.38 per pound. Okay, that is your unit rate, your rate of change, your slope. So is this table proportional? How could we check? Okay, if you divide 1104 divided by 8, you get $1.38. If I throw my calculator, 16.56 divided by 12, $1.38. 2208 divided by 16, $1.38. So that shows, yes, it's proportional. How do I know? The ratios y over x all equal $1.38. So what would be the equation of this table? Y equals $1.38. That's per pound. So we could multiply that by any x value amount of pounds to get my y value, my cost. Okay, so here on number 2, I just want you to use the graph to answer the questions. So this should be quick and easy review. So I want you to tell me what is the slope of this. I will help you to see by finding 2 quick points. That one crosses. 0, 0 is always an easy one on your y-axis. Okay, pay attention to your axes. What do they go up and over by for rise and run? Answer, what is the slope? Is this graph proportional? How do you know? And write an equation for this graph. Now we're going to start looking at non-proportional relationships. So if proportional relationships are a straight line that pass through the origin and all the ratios are constant, if you had to guess, what do you think a non-proportional relationship would be? You probably have the right idea. A relationship between two quantities is non-proportional if the ratio between the two quantities is not constant. A graph of a non-proportional relationship will not pass through the origin. We started to see a couple graphs like that this week. Instead, the graph will cross the y-axis at a point known as the y-intercept. So what should be true about the x value of an ordered pair for a y-intercept? We're going to take a look at this in a second. And I want you to take a look at this example. We're going to come back because not all graphs will go through the x values. I'm going to show you an example in just a minute. We'll come back to that. So in this example, in her search for a gym, Hillary found a location that charges $10 as a one-time sign-up fee and then $20 each month. So complete the table to show the relationship between the number of months at the gym and the total membership. So last time it was just $25 per month, no sign-up fee. This time there's a $10 one-time sign-up fee and it's $20 a month. So how is this going to be different? So if she signs up and she hasn't gone for any months yet, how much money is she going to have to pay? Well, it costs $20 a month and she hasn't paid any in 0 months. So she's gone for 0 months, but you're still going to have to pay that sign-up fee as soon as you start. So at month 0, she's going to pay $10 just to sign up before she even can go to the gym for 0 months, day 0. Okay. So next process, if she goes for 1 month, it's $20 a month. So she pays for 1 month plus her $10 sign-up fee. 20 times 1 is 20 plus 10 is 30. Month 2, $20 a month times 2 months plus the $10 sign-up fee. 20 times 2 is 40 plus 10 is 50. 20 times 3 months plus $10. 60 plus 10 is 70. 20 times 4 months is $80 plus the $10 sign-up fee is $90. So if I wanted to know X number of months, you multiply $20 times however many months you want to know, plus that $10 sign-up fee is going to give you what is on the Y axis. Okay, so what is the slope or rate of change shown in this table? So what is our rate of change? What is our total cost going up by, our Y value going up by? It is going up by 20 divided by 1, because your X number of months is going up by 1. So 20 divided by 1 is 20. So my rate of change is $20. We knew our rate of change was $20 each month. But what is the value of the y-intercept? So on the y-intercept, at 0 months, are we going to start at 0, 0? This time we're not starting at 0, 0. We're starting at 0, 10. So if you look at my graph over here, because my X value is months, my Y is your cost. At 0 months, you're going to have to pay that $10 sign-up fee. So what would my y-intercept be here? My y-intercept is going to be 10. So is this table going to be proportional? No. Couple of reasons. Okay. All ratios are not constant. And this line is not going to go through the origin, because if you look, 30 divided by 1 is 30. 50 divided by 2 is 25. Right there, those are different ratios. So this graph would not be proportional. Why is it not proportional? Because that sign-up fee made it not proportional. That made it start over here on our graph at 0, 10. At 1 month, she paid $30. 2 months, she paid $50. 3 months, she paid $70. 4 months, she paid $90. So yes, it may appear proportional in terms of the line, but remember, it does not start at 0. So after 0 months, it's proportional, but overall, it's not proportional. It does not pass through that origin. So what's the slope or the rate of change here? Okay, if you look at your rise over your run, 10 to 30 is a change of 20 over 1 month. Up 20 over 1. Up 20 over 1. So your slope or your rate of change here is still $20. What's the value of your y-intercept? It's still 10. There's my y-intercept. So is this graph proportional? No, we talked about why, because it does not pass through the origin. Okay, so let's take a look at our last piece here. So my equation. Write an equation to represent the relationship between X, the number of months at the gym, and Y, the total cost of the membership. So we always start with Y equals, what does it cost per month? It costs $20 per month plus a $10 sign-up fee. So do you see the slope in the equation? Where is your slope here? The slope is still in front of your X. That's not going to change whether it's proportional or not proportional. So my slope is still 20, and it's still that coefficient in front of the X, the number in front of the variable. Do you see a y-intercept? So that's my M, my slope. Your y-intercept, where did it cross the y-axis? At positive 10. So my B, or my y-intercept, is added on the end because it's a positive 10. Okay? And part D, what conclusion can we make about non-proportional equations? We know that the slope is the coefficient of X, and the y-intercept is that added or subtracted value at the end attached behind the variable, okay? So non-proportional equations will be written in the form of y equals mx plus b, where m is your slope, b is your y-intercept. This is a linear equation, the equation of a straight line that's not proportional. Okay, so my linear equation. Now, if it's not proportional, you're going to have the y-intercept right here. If it's proportional, it's just going to be that part because it's always going to go through what? If it's proportional, it's going to go through 0. So that will be plus 0 always. So you don't need to put that there. Okay, so right here, for each equation, 1 through 3, I want you to list the slope, y-intercept, and whether or not it's proportional. So take a look at this. Does this have a y-intercept right here? It does. So this one is going to be, is this going to be proportional or not proportional? Does it cross through the origin? It does not. It's going to cross through the y-intercept at positive 9. So proportional? No. What's the slope here? Your slope is right there, negative 4. My y-intercept is positive 9. For this one, is this proportional or not proportional? Hopefully you answered not proportional. Why? Because it's got a y-intercept different than 0. So my y-intercept, or my b, is negative 8. My slope is right there. My m is 3/4. Last one here. Is this proportional or not proportional? This one is, yes, it's proportional because does it have a y-intercept other than 0? It does not. So my y-intercept here would be 0 because there isn't anything added here. It's going to cross through the origin. But my slope is right here, my coefficient in front of x. My slope is 1.25. So let's take a look at a word problem, and then that's it for the lesson today. Caroline is going to the state fair with a group of friends. It cost her $12 for admission. That's $12 to get in. And once she's inside the fair, she can buy tickets for 75 cents each in order to play games, purchase food, or go on rides. So it's $12 to get in, and it's 75 cents for each ticket. So let's write an equation to represent the relationship between the total cost and the amount of tickets as your x. So what is your slope or your rate of change? What's changing here? What do you think? So our slope or our rate of change, each ticket costs 75 cents. So that can change however many tickets you want to buy. But what's set is that $12 for admission. That's going to be that one-time fee to get in. So even if she buys 0 tickets, what does she have to pay just to get into the state fair? She has to pay $12 just to get in, even if she buys 0 tickets. So knowing that our slope or our rate of change is 0.75 and our y-intercept is 12, how could we write an equation? To find your total cost, the y, you're going to pay 75 cents per ticket plus $12 admission to get in. So you're going to pay 12, even if you bought 0 tickets, 75 cents times 0, plus the $12 to get in. So if you bought 1 ticket, it would be 75 cents times 1. That would be 75 cents plus $12 admission would be $12.75 would be our total, and so forth and so on based on the number of tickets, because that could change. So describe what the graph of this relationship would look like. It would begin, which is why y-intercept is letter B. It would begin at 0.12, at the point 0.12 on the y-axis. And then after that, the line would be straight with a constant rate of change or slope of 0.75. So it's going to go up 75 cents per ticket, up 75 cents over 1, up 75 cents over 1, up 75 cents over 1. That is our lesson for today. Have a great Friday and a great weekend.